Hello, I'm Desone Burns. I'm an undergraduate at the University of Arizona. America currently faces a dilemma that will determine the fate of the planet for years to come. As of right now, I could go up to my room, flip a switch, and the lights will turn on. Basically, the production of energy in America is enough to keep up with the demand. But how is this energy being produced? Is it clean? If not, what can be done to change that? What methods could be incorporated to make sure that our skies stay clear and clean? As I said, energy production as of right now is doing a great job keeping up with demand. I'm sure I'm not the only one who thinks gas prices are outrageous, but as long as I have the money, I can fill up my gas tank. Since most of my diet as an undergraduate consists of frozen foods and ramen noodles, it's important for there to be enough electricity for me to use my microwave. Luckily, that's not something I have to worry about, as the electricity is there. Now, the fact that the electricity is there is fine and dandy, but where is it coming from? I'm paying for it, but where is my money going? Here's a pie chart showing energy consumption by source. We have coal, natural gas, and petroleum taking up most of the space on this chart. These are fossil fuels that release carbon that was once stored in the ground. Carbon that was removed from the carbon cycle, a very delicate balance the Earth must maintain in order for surface temperatures to be habitable. The burning of fossil fuels releases so much carbon that the temperatures on the surface are actually changing, causing the polar ice caps to melt. Something definitely needs to be done to stop this process. Luckily, steps are already being taken to do just that. Renewable energy is energy that does not rely on fossil fuels, preventing the release of fossil fuel emissions. Coming back to the pie chart, I mentioned the three chunks that take up the most space. Still remaining is nuclear electric power, which doesn't release greenhouse gases but is dangerous. And finally, renewable energy, 9% of energy consumption in the United States in 2011. The bulk of this is hydro 5%, then wood at 22%. Then we come to the smaller, still developing ones that I personally like the most. 21% of the energy consumed was from biofuels like ethanol and biodiesel. These can be produced in large quantities at rapid speeds and can be integrated into existing technologies, providing an easy and smooth transition into the future of energy production. Possibly the most ambitious and promising in the field of biofuels is microalgae. It's an extremely simple process. You take a pool of water and throw on a propeller to stir it around. Add some microalgae to start the growth, and within days, given the water is a habitable temperature and there's enough sunlight, the algae will multiply and turn the water green. The water must then be evaporated, leaving dry algae. Through a few chemical processes, the dry algae can be turned into a fuel which is already compatible with any vehicle that runs on diesel. With the only requirements being carbon dioxide, water, and sunlight, algae can be grown almost anywhere. It can be put on rooftops and backyards. It can even be paired with blinds to provide shade and energy, essentially reducing energy consumption in the form of cooling and providing it energy by definition. Basically, algae biofuel could be the future of energy production. In addition to algae, there are other sources like wind and solar that are growing in popularity. These two sources generate electricity, which can be put in some very new cars that have hit the streets in recent years. But what if more energy could be packed into a car for greater range and more power? Hydrogen fuel cells are not a new technology, but they have a great potential. They are as simple as putting electrodes into distilled water and collecting the gas that comes from the negative terminal. When burned, hydrogen does not produce carbon dioxide, but instead water. This means absolutely no carbon emissions, but this comes at a price. Hydrogen technologies are extremely expensive and would have to replace current technologies. While hydrogen fuel cells could eventually provide a carbon-free energy cycle, it won't happen for a very long time. Possibly if paired with other renewable energy sources, it could come sooner. But for now, there are more plausible renewables. Just as important as producing clean energy is reducing energy usage. In recent years, America has done a great job at that, but more work still needs to be done. The lower the amount of energy consumed, the less ground renewables will have to cover. This means that if America consumes less energy, renewables will replace fossil fuels even faster, which benefits the Earth immensely. As long as energy consumption continues to decrease, renewables could be coming in the near future. In closing, America is doing a fine job of keeping up with energy needs. However, current methods are costly to the environment, to say the least. Carbon emissions from fossil fuels are causing the Earth to heat up and could cause some catastrophic geologic events. That being said, there are technologies being implemented now that will eliminate the need for fossil fuels. These include wind, solar, hydroelectric generators, and possibly the most promising, microalgae biofuel. Other future technologies like hydrogen fuel cells could be used in the not-so-near future, but for now, carbon-neutral fuels like algae will do a fantastic job of keeping up with energy needs. Best of all, algae can be grown almost anywhere, and hardly takes anything to grow. As of right now, America is able to keep up with energy needs by burning fossil fuels and polluting the atmosphere with carbon. But in the future, no more carbon will be released thanks to renewable energy sources like algae biofuel.